Asalam-o-Alikum and welcome back. So in this chapter, test of hypothesis and significance, we continue with the help of examples. So what is this? A test has been given for many years with mean score 60 and standard deviation 8. A group of 50 students were selected and gives a special training. These 50 students obtain an average score of 65. Can we say that special training has changed the score? Here we use the alpha, which is 0.05, or we can say 5%, and this is about two-tailed test. So solution इसका देख लेते हैं. Null hypothesis where h naught equals to mu equal to 60 and h1, or we can say the alternative hypothesis where mu not equal to 60. This is about two-tailed test. So level of significance is 0.05 and the test statistic are z equals to, we write the formula which we will use in this example, and it is equals to z equals to x bar minus mu naught divided by sigma by square root n. Sigma divided by square root n. So the calculation of this is z as it is, because we use the z formula. So here x bar is 65 minus mu naught, which is 60. These all values are given in the example already. What is the standard deviation, or we can say sigma? So sigma value is 8 and the square root the value of n. So n is number of student, or we can say 50 students. So there is 50. So the critical region where z equals to, or z lie, z is less than minus 1.96, 1.96, or z is greater than 1.96, or z is greater than 1.96. So conclusion is the calculated value of z is greater than 1.96, because the value is, after calculation, the value is 4.41, which is greater than 1.96. So we reject the null hypothesis. So the question is how we find these values, like z is lie between 1.96 plus and 1.96 minus. So for this we have to remember these values, like we have level of significance, level of significance, and So for level of significance, we have 1% or 0.01. We already know that 1% is 0.01. The next is 5%, or we can say 0.05. The next is 10% or 0.001. So for critical region or for one tail test, we have critical region for one tail test. So CR is the critical region for one tail test. For one tail test. And critical region for two tail test. Critical region for two tail test. So for 1% we have two values like plus 2.33. So plus and minus, plus minus 2.33, from plus to minus, and for one tail test. And for two tail test, critical region, critical value for two tail test, we have 2.58 plus and 2.58 minus. So plus minus 2.58 plus minus. The next is 5%. So for 5%, for one tail test, we have the value from plus to minus 1.645. And for two tail test, we have 1.96. As we already discussed in the previous slide, 1.96 plus and 1.96 minus. So plus minus 1.96. The next is 1.28. So for plus and minus 1.28. If we have critical, we have the value of alpha is 10 or 5 or 1. So we have to remember these values: 1.28 plus and 1.28 minus. For one tail test and for two tail test, we have from plus to minus 1.645. 1.645. In diagrammatical form, if we have two-tailed test, as we already discussed in the examples, that we have two-tailed test example. So here the value is from the peak, we have the scale like this. So the value of z in at this point is 0, z equals to 0, and this is the critical region and this is the critical region. So in this we have 1.96 because this is two-tailed test and the level of significance was 5%. So minus 1.96 and plus 1.96 plus 1.96. This is the critical region, and this one is the acceptance region. This is the acceptance region. Acceptance region. And the shaded area is critical region. So this is the critical region. This is the critical region. So if the value is, if if the calculated value of C is greater than 1.96, so we reject the null hypothesis. So in this case, we reject the null hypothesis because the value is 4.41 and the critical value is 1.96. So it lies in the critical region. So we reject the null hypothesis. Is it this region? So we reject the null hypothesis.
Now next example is the manufacturer of Star motorcycle advertised that the motorcycle will average 87 km per liter of petrol. A sample of 8 bikes revealed the following: 88, 80, 82, 81, 87. There are different numbers. So at the 5% or 0.05 level of significance, is the mean mileage is less than the advertised 87 km per liter of petrol. So what is the solution for this example? The first step is null hypothesis and the alternative hypothesis, where mu is equals to 87, and the second null alternative hypothesis is mu is less than 87. This is one tail test, so the level of significance is 0.05 is already given in the example. So what is the test statistic? We use the same formula as we already used in the previous example. That is test statistic. We use the formula T equals to x bar minus mu naught whole divided by s square root divided by square root n. So what is the computation? We have the values x and we will calculate from these value the mean value, or we can say x bar mean value, or we can say x minus x bar. So and the next is x minus mean का whole square, or we can say x minus x bar का whole square. इसको हम ऐसे भी लिख सकते हैं like x minus x bar whole square. So we have the total values of x is 664 and the x minus x bar का होल स्क्वायर, और इसका जो हमारे पास टोटल आ रहा है वो 132 है. अब हम यूज करेंगे फार्मूला को, लाइक हमारे पास एक्स बार कैसे आया। एक्स बार को कैलकुलेट करने के लिए हमने फार्मूला यूज किया समेशन एक्स डिवाइडेड बाय एन। समेशन एक्स हमारे पास है 664 divided by number of observation, which is 8. So the value is 83. So this is the value of x bar. Now we will calculate the next values. Like we have to calculate s square. So for s square we have the formula summation x minus x bar का whole square divided by n minus 1, and we have the answer 132 as we already calculated from the table, divided by n minus 1. N is 8 or 8 minus 1 is 7. So the answer is 16.5. The next is what is the value of s, because this is s square. So the s is 4. सिंपली s स्क्वायर का स्क्वायर रूट करके हमारे पास इसकी वैल्यू आ जाएगी, which is 4.062. So what is the t statistic? For t statistic we use the formula as x minus x bar minus mu divided by s and divided by n square root n. So we have to put the values in this formula. 83 minus 87 and divided by 4 point, which is s. So 4.062 and whole divided by square root n, which is 8. So these values is equals to -4 into 2.28, sorry, 2.28 427 4 2 and 7 and divided by 4.062, and this is equals to minus 2.79. So the critical region, or the fifth point, is critical region CR. T is less than T calculated, or we can say T alpha n minus 1. When h equals to when h1, or we can say alternative hypothesis. Mu is less than mu naught. So here T is 0.05. In this we use the T statistic table. So n minus 1 is 7. So we have to find out the value of T, which is 1.895. 1.895. So critical region is T less than 1.895. 95. So conclusion is we reject the H naught or the alternative hypothesis. Conclusion is H naught is rejected. We reject H naught.